It was 3 a.m. A senior engineer, 5 years of experience, hundreds of deployments, stared at a broken pipeline on their screen. The tests were green locally. The Docker image built fine. But every single deploy was failing, and the error message was useless. After 3 hours of digging through logs, reverting commits, questioning every life choice that led to this moment, they found it. A single space. 2 spaces where there should have been 4. A GitHub Actions step that looked perfectly reasonable to the human eye was structurally broken to the YAML parser. That one character difference, invisible at a glance, cost 3 hours of a senior engineer's time. This is YAML. It is deceptively simple. It reads like plain English. It looks clean and elegant. And it is devastatingly unforgiving. In this chapter, we're going to master the YAML you actually need for GitHub Actions. Not all of YAML, just the parts you'll use every single day. We'll cover the basics, the gotchas, and the advanced patterns that separate engineers who fight YAML from engineers who command it. By the end, that 3 a.m. scenario? You'll spot the bug in seconds. Let's begin. YAML stands for YAML Ain't Markup Language, a recursive acronym that tells you exactly what the designers wanted to distance themselves from. This isn't XML. This isn't HTML. YAML is a data serialization format, a way to represent structured data that a human can actually read without wanting to close the terminal. Compare it to JSON, which GitHub Actions previously used in some configuration contexts. JSON requires curly braces to open objects, square brackets for arrays, double quotes around every string, and commas between every element. One missing comma and the whole thing breaks. JSON was designed for machines. YAML was designed for people. In YAML, you don't need braces. You don't need most quotes. You just write key value on a line, indent children under their parents, and you're done. The catch? That elegant simplicity is powered by whitespace. Indentation isn't decorative in YAML, it is the structure. 2 spaces versus 4 spaces is the difference between a nested child and a sibling. A tab instead of spaces will break the entire document in most parsers. GitHub Actions workflows are 100% YAML. Every workflow file in your .github/workflows directory is a YAML document. Mastering this format isn't optional, it's foundational. Every YAML document, no matter how complex, is ultimately built from one primitive, the key-value pair. A key, followed by a colon, followed by a space, followed by a value. That's it. That's the atom. Keys are typically strings. Values can be strings, numbers, booleans, lists, or nested mappings. Most of the time this is totally intuitive. But booleans have a trap that catches everyone at least once. In YAML 1.1, which is the version many parsers use, the words true, false, yes, no, on, and off are all recognized as booleans. True and yes and on are all the same value, boolean true. False and no and off are all boolean false. Why does this matter for GitHub Actions? 2 reasons. First, if you write a value like yes meaning the string yes, such as a branch name or an environment flag, you might silently get boolean true instead. Second, and more famously, the key on at the top of every GitHub Actions workflow, the trigger configuration key, is also a boolean keyword in YAML 1.1. So when you write on push, some YAML parsers think you wrote true push. In practice, GitHub's parser handles this correctly, but linters will warn you, and the safe habit is to always quote it. We'll cover that in depth in the intermediate section. For now, remember, when in doubt, quote the value. Quotes make the type explicit. If key-value pairs are the atoms of YAML, lists are where YAML gets interesting and where GitHub Actions makes its most important use of the format. A YAML list, also called a sequence, is written using a dash followed by a space before each item. Each item lives on its own line at the same indentation level. This is called block style, and it's what you'll use almost exclusively in GitHub Actions. There's also flow style, where you put the list inline using square brackets, on, push, pull _ request. You'll see this frequently for the trigger configuration because it's compact and readable for short lists. Both styles are valid YAML, and they can even be mixed within the same file. Here's the connection to GitHub Actions that makes this concrete. The steps key in every job is a YAML list. Every step you write, whether it's a uses step for a community action or a run step for shell commands, is a dash prefixed list item. The step's name, uses, run, env, and with properties are all key-value pairs nested inside that list item. This nesting is where indentation becomes critical. The dash that starts a step sits at one indentation level. The properties of that step name, uses, with, must be indented further than the dash. Get that wrong, and you've either merged 2 steps into one, or created a step without any properties. Dashes are structural in YAML. They're not bullets. Their syntax. Now we get to the heart of YAML structure and the heart of the 3am debugging story from slide 1. Nested mappings are how you represent hierarchical data, and in GitHub Actions, that hierarchy runs deep. The rule is simple: each level of nesting requires exactly 2 more spaces of indentation than its parent. Top-level keys, name, on, jobs start at column 0. The job names under the jobs key are at 2 spaces. The jobs properties runs on, steps, env, are at 4 spaces. The step list items are at 6 spaces. The step zone properties, name, uses, run, with, are at 8 spaces. And nested configuration under with goes to 10 spaces. 2 things break this immediately. First, tabs. YAML spec forbids tabs for indentation. Always. If your editor is inserting tabs, even invisible ones, your YAML will fail. Configure your editor to insert spaces for YAML files, always. Second, siblings out of alignment. If you have 2 properties that should be at the same level, say runs on and steps, which are both children of a job, they must start at exactly the same column. Even 1 space off in YAML will misread the hierarchy. The best mental model: visualize your YAML as an outline. Every level in has its own indentation. Siblings are always at the same level. Never dead end without closing a level. Keep a consistent 2-space rhythm and the structure becomes readable at a glance. YAML gives you 3 ways to write a string value, and knowing when to use each one is the difference between clean, readable workflows and subtle silent bugs. The first way is unquoted. No quotes at all, just the value after the colon. This works for most strings, names, references, labels, paths. It's the most common in GitHub Actions workflows. The downside is that YAML will try to interpret the value as a native type first. If it looks like a number, it becomes a number. If it looks like a boolean, it becomes a boolean. The second way is single quotes. Single quoted strings are completely literal, no escape sequences are processed. The only special case is representing a literal single quote, which you do by doubling it, 2 single quotes in a row. Single quotes are perfect for values that contain special characters like colons, hash signs, or words like true and false that you want as strings. The third way is double quotes. Double quoted strings process escape sequences, \n for new line, \t for tab, Unicode escapes. Use double quotes when you actually need those escape sequences. They're also necessary when your string contains characters that would confuse the YAML parser. The practical rule of thumb: write values unquoted by default. Switch to single quotes whenever the value contains a colon, starts with a special character like a curly brace, or could be misread as a boolean or number. Use double quotes only when you need escape sequences. When uncertain, single quotes are your safest fallback. Once you start writing real GitHub Actions workflows, you'll immediately hit a situation where a single run command spans multiple lines, multiple shell commands, a complex script, or a long pipeline. YAML has 2 operators for multi-line strings, and mixing them up silently breaks your workflows in frustrating ways. The pipe character, the vertical bar, creates what YAML calls a literal block scalar. After the pipe, everything indented on the following lines becomes the string value, and crucially, every new line is preserved exactly as written. When you write run, pipe, then 3 indented shell commands on separate lines, GitHub Actions receives 3 separate commands separated by new lines, which the shell runs sequentially. This is exactly what you want for a multi-step run block. The greater than sign creates a folded block scalar. New lines within the block are converted to spaces. Only blank lines become actual new lines. This is useful for long prose descriptions or documentation strings where you want to wrap lines for readability without inserting literal new line characters into the value. The mistake everyone makes: using greater than for a run block with multiple commands. Instead of 3 separate shell commands, you get one very long command with all the new lines collapsed into spaces, and it silently fails or behaves unexpectedly. The GitHub Actions rule of thumb is simple. Always use the pipe for run steps. Use greater than only for description fields or other prose values. If you're writing shell commands, pipe is your friend, always. This is the most infamous YAML gotcha in the entire GitHub Actions ecosystem. Every single workflow file starts with the on key to configure triggers. And in YAML 1.1, the version most parsers implement, on is a recognized Boolean keyword, synonymous with true. When a strict YAML 1.1 parser encounters on push, it doesn't read a key named on. It reads a key with value Boolean true, mapped to the list, push. So the semantic meaning becomes, true maps to push, which is nonsensical. The parser might throw an error, or silently produce a broken structure. GitHub's own YAML parser handles this edge case correctly because they know their own keyword. But here's where it bites you: the YAML linter, VS Code's YAML extension, CI validation tools, pre-commit hooks, many of these will warn or error on the bare-on key. You push a change, the pre-commit hook fails, you get a confusing error, you spend 15 minutes investigating something that has a 5-second fix. The fix is simple: quote the key. Right on, with single quotes surrounding on. This makes it unambiguously a string key, not a Boolean keyword. The YAML parser sees a quoted string named on and maps it to your trigger configuration correctly. In practice, you'll see both quoted and unquoted on in workflows on GitHub. The unquoted version works in GitHub's parser. But the professional habit, the one that makes linters happy, makes the intent clear, and avoids ambiguity, is to always quote it. As your GitHub Actions workflows grow, you'll notice repetition creeping in. The same environment variables defined in 3 different jobs. The same defaults repeated across every job block. Every time you repeat yourself, you introduce risk. If you need to change that value, you have to find and update every copy. Miss one and you have a subtle bug. YAML's answer to this problem is anchors and aliases. An anchor is defined using the ampersand symbol followed by a name. You place it on a mapping or a value. Anywhere else in the document, you can use that same name with an asterisk to paste in the anchored value. That's the alias. The pattern I recommend for GitHub Actions is using extension keys that start with X-, which GitHub ignores, to define your shared blocks at the top of the file where they're easy to find. Define xenv, &env with all your shared environment variables as children. Then in each job, write env, *env. The YAML parser replaces the alias with the full mapping. This keeps your workflow files dry, don't repeat yourself, and makes changes much safer. Update the anchor definition once, and every job that uses that alias gets the update automatically. 2 things to remember: anchors must be defined before they're used. And the anchor name should be descriptive, treated like a variable name. Good names make the intent obvious when someone reads the file 6 months later at 3 a.m. The $double curly brace syntax you see throughout GitHub Actions workflow files is not YAML. It's GitHub Actions' own expression language, and it's evaluated by GitHub's runtime before the YAML is fully processed. This distinction matters because it creates a collision between 2 syntaxes. YAML also uses curly braces for flow mappings, inline object notation. When YAML sees a value starting with a $sign and curly brace, it sometimes interprets the inner content as a flow mapping, causing a parse error. The rule is, any YAML value that starts with the $sign curly brace expression syntax must be wrapped in quotes. Write the whole value as a quoted string, single quotes around the expression. This tells the YAML parser to treat the entire value as a literal string, and then GitHub Actions evaluates the expression inside. Values that start with something else, a word, a number, and only contain the expression in the middle or end are usually fine without quotes. But when the expression is the entire value, or starts the value, quote it. The expression syntax gives you access to contexts: the GitHub context for repository information, the secrets context for encrypted secrets, the env context for environment variables, and many more. These are powerful, but they're GitHub Actions concepts, not YAML. Think of the YAML as the container and the expressions as the dynamic content inside that container. They play by different rules, and you need to manage where those rules intersect. Comments in YAML work exactly like you'd expect from most programming languages. The hash symbol starts a comment, and everything from the hash to the end of the line is ignored by the parser. Comments can appear on their own line or at the end of a line after a value. What makes comments interesting, and occasionally confusing, is how they interact with multi-line string blocks. Inside a run, pipe block, the hash character becomes a shell comment, not a YAML comment. The YAML parser has already handed off that entire block as a string to the shell. So inside a literal block scaler, you're playing by shell rules, not YAML rules. This is actually useful. It means you can comment individual commands within a run step. The philosophy of good comments in workflow files is the same as good comments in any code: explain the why, not the what. The YAML itself shows what it does: it runs npm test, it deploys to production, it checks out the repository. What the code can't show is why you made specific choices. Why Ubuntu latest instead of Ubuntu 22.04? Because you need the newest Docker daemon version. Why is continue on error set to true for this step? Because it's a flaky third-party API call that shouldn't fail the whole build. Those explanations are where comments add real value. Avoid over-commenting. A workflow file full of comments explaining what every step does becomes harder to read than one without them. Be selective. Comment the surprising, the non-obvious, the architectural decisions. The best time to catch a YAML error is before you push to GitHub. Every failed pipeline run costs you minutes waiting for a runner to spin up, waiting for the error to appear, waiting for the rerun after the fix. A local linter catches the same error in milliseconds. YAMLint is the standard command line YAML linter. Install it with pip, run YAMLint against your .github/workflows directory, and it immediately reports syntax errors, indentation issues, and style problems. You can customize its rules with a configuration file. Most teams configure it to enforce two-space indentation and warn on unquoted Boolean keys like on. ActionLint goes further. It's a specialized linter for GitHub Actions YAML specifically. It understands the actions schema, validates that your use's references point to valid actions, catches type errors in expression syntax, and identifies action-specific problems that YAMLint doesn't know about. It's one of the highest value additions to any team's pre-commit hooks. For in-editor feedback, the Red Hat YAML extension for VS Code combined with the GitHub Actions JSON schema gives you real-time validation and autocomplete. As you type, it tells you when a field name is wrong, when a required field is missing, and offers completions for valid values. The schema file is maintained by the open-source community and tracks GitHub Actions supported syntax closely. GitHub's own built-in check triggers after you push and shows errors in the Actions tab with line numbers. Think of this as your last resort, the validator you hit when everything else missed something. Aim to never need it. Let's look at a real-world advanced indentation mistake, the kind that YAMLint catches but the human eye often misses on first read. The scenario: you have a job with a step that uses a community action and passes it configuration via the with key. The step is correct, the action reference is correct, the configuration is correct. But the with key is at 6 spaces instead of 8. At 6 spaces, with is at the same indentation level as the step list items dash. In YAML's view, this makes with a new list item in the steps array a step with only a with key and no uses or run key, which is invalid. Meanwhile, the previous step has a uses but no with, so the configuration never reaches the action. GitHub Actions silently uses default values or fails with a cryptic error about missing required inputs. The fix is 2 spaces further in. 8 spaces puts with as a child of the step item, making it the configuration for that action. How to train your eye to spot this: count the spaces from the left margin to each key. Draw a mental vertical line down the file. Properties of the same step should all start at the same column. If uses is at 8 spaces and with is at 6, something is wrong before you even run the workflow. This is also why visual YAML formatters and editor extensions that show indent guides are so valuable. The structure becomes visually obvious rather than requiring you to count characters. YAML's automatic type conversion is helpful when it works and catastrophic when it doesn't. The parser tries to be smart about what type a value is, and that intelligence occasionally destroys your intent. The most infamous example in the GitHub Actions world is Python version numbers. If you write Python version 3.10 without quotes, YAML parses that as a floating point number 3.1. The trailing 0 is dropped. Your setup Python action receives the string 3.1 and installs Python 3.1, or more likely fails because 3.1 is ancient. The fix is to quote it, Python version 3.10, which is unambiguously the string 3.10 with the 0 preserved. The same caution applies to any version number that looks like a float, 3.10, 3.9, 2.0. The rule is simple: quote all version strings. Always. The Boolean coercion trap is similar. If a step property expects the literal string yes or no as a configuration value, bare yes or no will become Boolean true or false instead. Quote them. YAML 1.1 also treats numbers with leading zeros as octal. So if you write a file permission mode like 0777, YAML converts that to decimal 511. If the action or script receiving that value expects the string 0777 for chmod style permissions, you get unexpected behavior. Quote permission modes. The general principle: when you're writing a value that has a specific format that matters, versions, modes, identifiers that happen to look numeric, single quote it and remove all ambiguity. Anchors and aliases let you reuse a block of values by pasting it in wholesale. But sometimes you want to merge a shared base with local overrides, inherit most properties from a template but change one or two. That's what the merge key operator enables. The merge key is written as 2 less than signs followed by a colon, double left angle colon. It takes an alias on the right and merges that mapping into the current mapping. Keys defined in the current mapping take precedence over keys from the merged mapping, so you get inheritance with override semantics. In practice, this looks like defining a job defaults anchor with common properties: Ubuntu latest runner, 10-minute timeout, continue on error false. Then in each job, you write the merge key pointing to that anchor, and locally override only what differs. A long-running build job might override timeout minutes to 30. A deployment job might keep all defaults unchanged. This is powerful for large workflow files with many similar jobs. It reduces repetition dramatically and makes the shared configuration change at one point. The caveat worth knowing, merge keys are specified in YAML 1.1 but removed from YAML 1.2. The YAML specification actually considers them non-standard in modern YAML. GitHub's parser supports them, and they work reliably in practice, but some strict linters will warn about them, and a future breaking change is theoretically possible. For most teams and most workflows, they're a pragmatic and valuable tool. Just understand what you're using. GitHub Actions gives you error messages when your YAML is broken. Those messages are technically accurate but often deeply unhelpful to anyone who doesn't already know what they mean. Let's decode the three most common ones. Mapping values are not allowed here means a colon appeared in a context where YAML didn't expect a key-value separator. The most common cause, a string value that contains a colon but isn't quoted. A URL and a value, a message with a colon, any text where the colon triggers YAML's key-value parser. Fix, quote the value. Did not find expected key is an indentation problem. A line is indented at a level that doesn't align with any parent mapping the parser is tracking. The parser is looking for a key at a specific indentation level and finds your content at the wrong column. Fix, check the indentation of the line GitHub points to and the lines immediately before it. The real error is almost always on the preceding line. Could not find expected colon means the parser expected a key value pair and didn't find one. Usually a block scalar or list item that wasn't started correctly, a missing space after a dash, or a pipe or greater than at the start of a run block that wasn't handled as expected. The meta-debugging strategy, always run YAMLint or ActionLint first, locally. GitHub's error messages tell you something is wrong but hide the exact nature. Local linters explain the problem in more detail. When the linter can't help, add explicit quotes around suspected values, simplify the structure, and re-add complexity incrementally until the error reappears. Before we close this chapter, let's lock in the most important technical concept you need to carry forward into every GitHub Actions workflow you write. You've seen the pipe character used in run steps throughout this entire chapter. You know it appears after the colon on the run key, followed by indented shell commands on the lines below. But can you precisely describe what it does and why it matters? This is a knowledge check, and it's also a mental model check. The distinction between the pipe and the greater than sign is one of those things that's easy to know in the abstract and easy to forget in practice when you're quickly writing a workflow at midnight. Getting it wrong produces workflows that appear to work, no YAML parse error, but fail at runtime in confusing ways. The pipe creates a literal block scalar. Every new line in the indented block below it is preserved exactly as written in the final string value. When GitHub Actions receives that string as the value of a run key, the shell sees exactly the multi-line script you wrote, with each command on its own line, executed sequentially. The greater than creates a folded block scalar. New lines become spaces. Your three-line script becomes one long run-on command that the shell almost certainly can't parse. Take a moment to select your answer. If you got it right, that understanding is the foundation of writing correct GitHub Actions workflows. If not, go back to slide 7 and reread the literal versus folded block breakdown one more time. It's worth the extra 2 minutes.